section 6.4 linear transformation. So let's start with the first example. Determine whether T is a linear transformation. We need to prove that this is T is a linear transformation. Our T is from matrices to a matrix defined by T to the matrix A equal A times B, where B is a fixed n times n matrix. So let's check how we're going to prove that. So the first thing, we need to apply the rule. The rule of a transformation says you have to prove these two conditions. The first condition, T A plus B is going to be T of A plus T of B. That means the transformation of the addition of these two matrices is going to be the same thing if you do the transformation for the matrix A plus the transformation for the matrix B. And the second condition is the transformation of the scalar times the matrix A is going to be the same thing, equal the scalar times the transformation of the matrix A. If you prove these two conditions, that means T is going to be a linear transformation. Our rule says here, with this example, transformation of A is going to be A times the fixed matrix B. So that's what we're going to do. So let's choose two matrices. I'm going to choose A1 and A2. Then the transformation of A1 plus A2. By using this rule is going to be A1 plus A2 times the fixed matrix B. Now I can distribute the matrix because this is one of the matrices rule. You can distribute this one. So this one is going to be equal A1 B plus A2 B. And this one is equal the transformation of the matrix A1, and this one equal the transformation of the matrix A2. So that means the first condition is right. Let's check the second condition. The second condition, we're gonna let C as a scalar. So I need to prove the transformation of C times A equal C, the scalar transformation of the matrix A. So this is the first part. Now the transformation of this one is going to be C times A times the matrix B. Now again, this is one of the matrices rule. This one is equal C and A times B. That means this one is equal C, the scalar, and this is the transformation of A. That's it. These two conditions is right. That means in this case, T is linear transformation. That's it for this example. So we're gonna type, just plug in yes. It's a linear transformation. So we got it right. Let's move to example 2. Example 2, determine T is a linear transformation. We have the transformation from the matrices to a number. Be careful to R. So it's mean from matrix to a number, defined by the transformation of the matrix A is going to be A11, A22. That's mean the multiplication of the diagonal. You see the multiplication of the diagonal row. So let's check how we're gonna prove that it's a linear transformation or no. We have to satisfy the two conditions. So the transformation from the matrices with dimension n times n to R, and here's the rule, which is the multiplication of the diagonal. I'm gonna let A, here's the matrix A, and here's the matrix B. So for the first condition, we're gonna say the transformation of A plus B is going to be equal. the transformation of the matrix A, which is A11, A12 until A1n, and AM1, AMN, plus the matrix B, which is B11 until B1n, and B so that means we're going to add these two matrices. So this one is going to be equal the transformation of the addition of these two matrices. It's going to be A11 plus B11, and until A1n plus B1n. And here is going to be B AM1 plus BM1 until AMN plus BMN. Now this is matrix. The transformation for this matrix is going to be the multiplication of the diagonal. So the result for this part is going to be A11 plus B11 times A22 plus B22, and keep going until AMN plus BMN. Now this is for the first side. For the second side, we need to prove that equal to the transformation of the matrix A plus the transformation of the matrix B. The transformation of the matrix A, here is the matrix A. If you want to write it down, if you want to do just the transformation, it's fine. The transformation for this matrix is going to be A11 times A12 and until AMN, plus the transformation of matrix B, not A, is going to be B11, B22, and until BMN. You can't add these because this is a number plus a number. But if you check the first part, it's going to be A11 plus B11. That means the transformation of A plus B is not equal to the transformation of A. So the transformation of A plus B is not equal to T of A plus T of B. In this case, T is not linear transformation. Linear transformation. And if you want to prove that, assume two matrices. Let's say A equal 1, 2, 3, 4, and B equal 3, 4, 5, 6. Let's check the transformation of A plus B, which is equal. Transformation of, let's add A and B. 1 plus 3 is going to be 4. 2 plus 4 is going to be 6. 3 plus 5 is going to be 8. 4 plus 6 is going to be 10. The transformation for this matrix is going to be the multiplication of the diagonal, which is 4 times 10, and this one equal 40. Now let's check the transformation of the matrix A plus the transformation of the matrix B equal. The transformation of the matrix A is going to be 1 times 4 plus the transformation of the matrix B is going to be 3 times 6. And this one equal 4 plus 18. And this one is equal to 22. This is just a special case to prove that this one is not a linear transformation. So we're going to choose it's not a linear transformation. That's it for this example. We got it right. Let's move to example 3. Determine whether T is a linear transformation. T is from all functions to the R denoted by T to F equal F with the C, where C is a fixed scalar. So let's check. We're going to do the same thing. We're going to satisfy the two conditions. So the first thing, we're going to let two functions, F1 and F2. So the first condition is going to be the transformation of F1 plus F2 is going to be equal, is going to be F1 plus F2 to the C. F1 plus F2 to the scalar C. This one is one of the functions rule. It's equal to the F1 to the C plus F2 to the C. And this one equal the transformation for the function F1 plus the transformation of the function F2. So here's the first condition is satisfied. The second condition, we're going to let P is a scalar. Then the transformation of P F, let's say F1, equal. The transformation of P F1 is going to be P F1 is going to be F1 to the PC. And this one is equal to the P F1 to the scalar C. And here is going to be the scalar times the transformation of the function F1. So that's it. This two conditions is satisfied. Then T is linear transformation. That's it for this example. So we're going to say T is a linear transformation. We got it right. Let's move to example 4. So example 4, they're telling you let T be a linear transformation from R squared to P with the degree 2 be a linear transformation for T of 1, 1 equal 1 minus 3x, and T, the transformation of 3 negative 1 equal x plus 3x squared. So let's check how we're going to solve this one, because they ask you find the transformation of negative 7 with 9 and the transformation from A and B. The first thing with this example, we need to find the coordinate of this vector, because that's what we need to find, the first part. So let's check how we're going to solve this one. The first step, I'm going to find the coordinate vector. So the first thing, we need to find the coordinates of 7, negative 9, and the base of 1, 1, 3, negative 1. So here is the base, the first column, and here is the second one, 3, negative 1. So that means we need to find the scalar. I'm going to write down this as a linear combination from the base. That means negative 7 and 9 is going to be equal C1 with the first 1, 1 plus C2 with the second one, which is 3, negative 1. So that's mean we need to solve this one. So the first one is going to be negative 7. Negative 7 is going to be equal C1 plus 3 C2. And 9 is going to be equal C1 minus C2. So I'm going to change the sign here. It's up to you how we're going to solve the system. That's mean cancel C1. So it's going to be negative 16 equal 4 C2. That means C2 is going to be equal negative 16 over 4. So C2 is going to be equal negative 4. Plug in negative 4 in one of these equations, you're going to get C1. So I'm going to plug in 4 here, which is negative 7 equal C1 plus 3 times negative 4. That means negative 7 is going to be equal C1 minus 12. Move the 12 to the other side, it's going to be positive. That means C1 is going to be equal 5. In this case, we have C1 and C2. Let's write down this as a linear combination from C1 and C2, but now I can find the transformation. That means the transformation for this one of negative 7 and 9 is going to be the transformation of 5 times this part plus the C2 is negative 4 times 3 negative 1, which is mean I can take the scalar out, so it will be 5, the transformation of 1, 1, minus 4, the transformation of 3, negative 1, and then equal 5, the transformation of 1, 1 equal 1 minus 3x, minus 4, the transformation of 3, negative 1 is going to be x plus 3x squared. That means this one's going to be equal. Distribute here, so it will be 5 minus 15x. Here is minus 4x minus 12x squared. Combine the log terms, so it's going to be 5 minus 19x minus 12x squared. I'm going to write down from the highest exponent to the lowest one. So it's going to be negative 12x squared minus 19x plus 5. So this is the transformation for negative 7 and 9. So we're going to type here. The first part is going to be negative 12x squared minus 19x plus 5. This is the first part. We didn't finish. We have to check the second part, find the transformation to the A, B. For the second part, it's going to be, we need to find the coordinates, the first thing. So it's going to be A, B equal C1 with the 1, 1 plus C2 with 3, negative 1. Again, it's up to you how you're going to solve it to find C1 and C2. And then after that, you can find the transformation. So here's the first one is going to be A equal C1 plus 3C2. And B is going to be equal C1 minus C2. Now solve this one. Change the sign here. This is a plus, is going to be minus. This is a plus, is going to be minus, and this one a plus. Cancel this one, so it's going to be A minus B is going to be equal 4C2. In this case, C2 is going to be equal A minus B over 4. So this is the value of C2. Now let's plug in C2 in one of these equations to get C1. I'm going to use the first one. So A is going to be equal C1 plus 3, and C2 is going to be A minus B over 4. That means A is going to be equal C1 plus 3, and here is A minus B over 4. Move this one to the other side. That means C1 is going to be A minus 3, A minus B over 4. This is over 1, so we're going to find the common denominator. I'm going to multiply this one by 4 and by 4. That's mean C1 is going to be equal 4A over 4 minus, here is a 3A minus 3. If you want to distribute the negative, because it's minus a 3, so this one is going to be plus a 3. Plus a 3B over 4. Combine the like terms, that means C1 is going to be equal 4A minus a 3A plus a 3B over 4. So C1 is going to be equal A plus 3B over 4. So this is the value of C1. And here's the value of C2. Now we need to find the transformation for AB. So the transformation of AB is going to be the transformation of AB is going to be equal the transformation of A is C1, which is C1 is A plus 3B over 4 times 1, 1 plus C2, which is A minus B over 4, 3, negative 1. Now the transformation for this one is going to be equal to the A plus 3B over 4 transformation of 1, 1 plus A minus B over 4, the transformation of 3, negative 1. This one is going to be equal A plus 3B over 4. The transformation of 1, 1 is going to be, if you go to the beginning, it's equal 1 minus 3x. So this is 1 minus 3x plus A minus B over 4. The transformation of a 3, 1, 3, negative 1 is going to be x plus 3x squared. Now, next step, we just need to combine the like terms, distribute, put down the terms with x squared and x and the number by itself. So what I'm going to do here, distribute this one here. So it's going to be this one equal A plus 3B over 4 times 1 minus everything times 3. So it's going to be this part times 3. So minus 3A minus 9B over 4, and everything here for the x. This is minus, we can keep the minus here, or if you want to distribute the negative sign, this one times negative 3, so it's going to be negative here. I keep the minus here, so it's going to be 3A minus 3B. Yes, 3B, and here is the x. Now this is a plus. A minus B times x over 4 on everything here times x. And this one times this one is going to be plus 3A minus 3B over 4 to the x squared. I kept the minus here outside, so this one is a plus. Now, let's combine the like terms, which is these together. That means the first term here is a plus 3b over 4. This one is going to be negative 3 minus, because I need to combine these together. So I'm going to say plus, here is negative 3a minus 9b plus a minus b, and everything is over 4 to the x plus, and here's a 3a minus 3b over 4 to the x squared. And then the result is going to be a plus 3b over 4 plus, here is going to be negative 3a plus negative 2a minus 10b over 4, and everything for the x, plus, and here 3a minus 3b over 4. You can put big parentheses or small x squared. That's it for this example. We can type everything here and check our solution. I typed my solution. The first term, this one, 1 over 4. I put 1 over 4 outside, 3a minus 3b, x squared. Then the term with the x, 1 over 4, negative 2a minus 10b, x, and the number by itself, which is the constant, is going to be 1 over 4a plus 3b. Let's check. We got it right. Let's move to example 5. Got it right. Let's move to number 5. Let T be a matrix with dimension 2 times 2 to the R be a linear transformation, and T to 1, 0, 0 equal 1, T to 1, 1, 0, 0 equal 2, and T to 1, 1, 1, 0 equal 3, T to 1, 1, 1, 1 equal 4. We need to find T to 2, 5, 1, 4, and also T to A, B, C, and D. The first thing, what I'm going to do here, I'm going to find the coordinates of 2, 5, 1, 4. So in the bases, here is the basis, which is the matrices here. Then is going to be 2, 5, 1, 4 equal C1, 1, 0, 0, 0, plus C2, 1, 1, 0, 0, plus C3, which is 1, 1, 1, 0, plus C4, which is 1, 1, 1, 1. So if you want to solve it as a system, 2 is going to be equal C1 plus C2 plus C3 plus C4. The first equation. The second one is going to be 5 equal, there is no C1, just C2, C3, C4. Can I write down C2 plus C3 plus C4. And 1 is going to be equal C3 plus C4. So C3 plus C4. And the last one is 4 is going to be equal just C4. If you want to convert this one to the matrix, then do the reduction. Or if you want to solve it by back substitution, it's up to you. Both is going to be right. So what I did, I convert this one to a matrix and did the reduction. So the matrix is going to be, I'm going to write down this number first, then equal, and 2, 5, 1, 4 is going to be on this side. So it's going to be 1, 0, 0, 0. And here is 1, 1, 0, 0, 1, 1, 1, 0. And the last column is going to be 1, 1, 1, 1. Then it's going to be 2, 5, 1, 4. I'm going to do the reduction. The new matrix is going to be 1, 0, 0, 0, and 0, 1. And the numbers here is going to be, which is the C, is going to be -3 and 4, -3 and 4. That's mean C1 equal -3, C2 equal 4, C3 equal -3, and C4 is going to be equal 4. So here is C1, C2, C3, and C4. Now we can find the transformation of this matrix. So T to the matrix 2, 5, 1, 4 is going to be the transformation of C1 with the first base plus C2, which is 4, with the second base plus C3, which is -3, with the third base, which is 1, plus C4, which is 4, with the fourth base, 1, 1, 1, 1. And this one is going to be equal -3 transformation of 1, 0, and 0, 0 plus 4 transformation of 1, 1, 0, 0 minus 3 transformation of 1, 1, 1, 0 plus 4 transformation of 1, 1, 1, 1. So this one is going to be -3 times the transformation of the first one is going to be 1 plus 4. The transformation of the second one is 2 minus 3. The transformation of the third one is 3 plus 4. The transformation of the fourth one is 4. So this one is -3 plus 8 minus 9 plus 16. And here is the result. It's going to be 5 minus 9 is going to be -4 plus 16 is going to be 12. So that's it for the first part of this example. So we're just going to put here is 12. Let's keep going on the second part. We're going to do the same steps, but we have to find the transformation of A, B, and C, D. So we're going to do the same steps what we did before, but now with the matrix A, B, and C, D. Find the coordinates with the bases. So C1 with the first base plus C2 with the second base plus C3 with the third base plus C4 with the fourth one. So now next step, A is going to be equal C1 plus C2 plus C3 plus C4. And B is going to be equal C2 plus C3 plus C4, and C is going to be equal C3 plus C4, and D is going to be equal C4. I'm going to convert this one to a matrix and do the reduction. So the matrix is going to be 1, 0, 0, 0, 0. Here's 1, 1, 2 zeros, 1, 1, 1, 0, and all ones. And here's going to be A, B, C, and D. By reduction is going to be here's identity matrix. And here's going to be A minus B, B minus C, and C minus D, and just D by itself. In this case, we have C1 is going to be equal A minus B, C2 is going to be equal B minus C, and C3 is going to be equal C minus D, and C4 is going to be equal D. Now we're going to find the transformation for this matrix. That means the transformation of A, B, C, D is going to be equal the transformation of C1, which is A minus B times the first base, which is 1, 0, 0, 0, plus C2, which is B minus C times the matrix 1, 1, 0, 0, plus C3, which is C minus D times the matrix 1, 1, 1, 0, plus C4, which is D times the matrix 1, 1, 1, 1. Now let's keep going. So the transformation for these is going to be the same thing. It's A minus B transformation of the matrix 1, 0, 0, 0, and plus B minus C, the transformation of the second base, plus C minus D, the transformation of 1, 1, 1, 0, plus D transformation of 1, 1, 1, 1. Then this one is going to be equal A minus B. Transformation for the first one is equal 1 plus B minus C. The transformation for the second matrix equal 2. So that means here's multiplication and the same thing here. A plus C minus D. The transformation for the third matrix equal 3 plus D. The transformation for the fourth one equal 4. So we're gonna maybe A minus B plus 2B minus 2C plus 3C minus 3D plus 4D. A, there is no A here, so here's A. Negative B plus 2B is going to be plus B. And negative 2C plus 3C, so it's going to be plus C. Negative 3D plus 4D, so it's going to be plus D. So that's it for this one. So we're just going to type, and the second part is A plus B plus C plus D. That's it for this example. We got it right. Let's move to the next example. Next example, 6. to find the linear transformation S from P1 to P2 and T from P2 to P1 by. So S to the A plus BX equal A plus BX and the 3BX squared. And the transformation T is A plus BX plus CX squared is going to be equal B, that means the second number here, plus the 3CX. Compute the S composite with the T to this polynomial and S composite to the T with this polynomial. Then they ask you to find T composite with the S to A plus BX. That means you have to do 3 parts for this example. So let's check here. Here's the two rules. The first thing I'm going to work on the first part. Before I start with the first part, we already know here S composite with the T is going to be to any number, let's say to U, is going to be S and T to the U. So this is the rule for composition. Now, the first part, I need to find S composite with the T to the 9 plus the 3x minus x squared. 9 plus the 3x minus x squared. So this one is going to be equal S and T to the polynomial 9 plus 3x minus x squared. And this one is going to be equal. Here's the S. T to this one. I'm going to use the transformation T. They're telling you the transformation of any polynomial with second degree with A plus BX plus CX squared is going to be the B by itself. The B here is a 3. So it's going to be 3 plus 3 times C. How much the C? The C is -1. So 3 times -1, and here is the X. I'm just using the rule. So this one is going to be S. Simplified is going to be 3 minus a 3X. Now, the next part, we're going to do the S transformation. The S transformation, it says A plus BX is going to be A. So where is the A here? The first number. This one is going to be the A. So it's going to be 3 plus A plus B to the X. So A plus B, that's mean A plus B, which is -3 to the X, plus 3B, which is -3 X squared. The result is going to be, this one is 0. So it's going to be 3 minus 9X squared. That's mean the first part, T composite with the S composite with the T is going to be 3 minus 9X squared. I'm done from the first part. Let's check the second part. If we need to find S composite with the T, but with the A plus BX plus CX squared. You're gonna do the same thing. So now S composite with the T to the A plus BX plus CX squared is going to be S and T to the A plus BX plus CX squared. Then this one is going to be S. Transformation for this one is going to be B plus 3CX. Now S to this part. S, here is the A, the first number, and here is the B with the X. So it's going to be, so be careful here. When you're using the rule, you're going to consider this one is the A, and you're going to consider this one is the B, because I'm using the rule with different symbols here, with different variables. So this one is going to be A, which is the first one, is B here, plus A plus B. This is A and this is B. So it's going to be B plus 3C plus, and here's the X, plus 3B. Here is the B, this is the B. So it's going to be 3 times 3C X squared. So here's going to be B plus B plus 3C to the X plus 9C X squared. That's it for this one. So we're gonna plug in on the second one is going to be B plus parentheses. It's going to be B plus 3C for the X. And it's going to be plus 9C X squared. This is the second part. Now they ask you to find T composite with the S. The third part, they ask you to find T composite with S to the A plus BX, which is equal T and S to the A plus BX. So it's going to be T S to A plus BX. So I'm going to go to the S plus B. So it's going to be T to the A plus B to the X plus 3BX squared. Because it's the same variables, so I'm not going to get confused. Now let's do the transformation for this part. When you do the transformation for this part with the T, this is A, this is B, and here is the C. So we're going to do the same thing. It's going to be B, which is A plus B, plus 3, and the C here is 3B X. So it's going to be A plus B plus 9B X. 9bx. You can put parentheses. You don't have to put parentheses because this is a coefficient, a constant, and here's a number with the x. So you can put parentheses A plus B, and here's going to be plus 9b with the x. That's it for this example. You got it right. Let's move to example 7. On example 7, they're telling you S is defined from P1 to P1 by is negative 4a plus b plus 2ax. And the transformation T from P1 to P1 divided by T of a plus bx is going to be b over 2 plus a plus 2bx. First of all, we need to prove that or verify that S composite with the T is going to be I with the P1, and T composite with S is going to be I with P1. Prove how much is going to be here and how much is going to be here by finding the composition between S and T. So the first thing, I'm going to find the composition between S composite with a T to the a plus bx is going to be equal s, and is going to be t to the a plus bx, and this one is going to be s t to the a plus bx is going to be b over 2 plus a plus 2b, and here is x. Now, if I need to find the transformation s to this one, keep in your mind, this one is going to be the a, and this one is going to be the b. So to find the transformation, we're going to use s, which is going to be negative 4a. That's mean negative 4 times this one. Negative 4, a is this part, which is b over 2, plus b, which is, this is b, which is a plus 2b. This is for the first part. Plus 2, a is b over 2, and here is x. Now let's simplify this one. Negative 2 with the 2, it's going to be negative 2b plus, here is a plus 2b plus, cancel these, bx. This is what this one is going to be 0, so the result is going to be a plus bx. So the first one is going to be a plus bx. I'm just going to type here a plus bx. Let's check the second one. T composite with s. 2 a plus bx. It's going to be the same thing. T is out, and here is s to the a plus bx. Then this one is going to be t. Now I need to find s to the a plus bx. S to the a plus bx is going to be negative 4a plus b plus 2ax. I'm going to keep it in mind. I need to find the transformation. This one is going to be the a, and this one is the b. To find the transformation t with the a, b, so it's going to be b divided by 2. Here is the b. So it will be 2a divided by 2 plus parentheses a, which is this part, that's mean negative 4a plus b plus 2b, which is 2a. Let's simplify this one. This one is going to be, cancel these, is going to be a plus, here's negative 4a plus b plus 4a. We forgot the x with the second part, so the x is going to be here. Now 4a cancel with the 4a, so the result is going to be a plus bx. So we got here a, also a plus bx. They're telling you thus this one is equal to the composition between t and s, which is equal a plus bx. That's it for this example. You got it right. This is section 6.4.